Hello guys. Today I've been come up with a new revolution of image classification. Actually, don't take it serious. This is not revolution, but yeah, you can say it's the kinds of revolution I have done. I have implemented a library. So I have named it ImageSeeker. It's an image classification library. Okay, and I think this library is really going to help that people who really don't know programming. Okay, and also this library will help that people. Okay, who are very lazy. Okay, so who don't want to code much. Okay, so yes, it will also help them because you don't have to worry about writing code. Okay, here, so you just have to click some of the button. Okay, so your work would be done. Okay, so what I have said, I will explain. Okay, just wait. So first of all, let me discuss about this image seeker. Okay, so how I got the idea and why I implemented that library. Okay, so ImageSeeker is nothing but I told you it's an image classification library. Okay, so ImageSeeker. If I talk about like more deeply, so you can see that ImageSeeker is a deep learning image classification library written in Python and running top of the machine learning platform TensorFlow.Keras. So it was developed with a focus on enabling the fast experimentation of image classification, and you can train and classify any images with any classification model in Keras application without writing any lines of codes. Okay, so this line really makes happy. Okay, and this is really great. Okay, I'm very happy because I've done such a works. Okay, so I've automated whole this image classification task. Okay, so you don't have to worry, so you don't have to worry about your data. Okay, about your data preparation, about your model preparation. Okay, so you don't have to worry about anything. Okay, what you need to do, you just have to configure some of the parameter, like where is your data is presented. Okay, and where is your validation data is presented. Okay, so you have to just give the path. Okay, and everything would be automated. Okay, and if you click the train button, okay, so it will automatically start train, so it will be automatically start training. And after training, you have to just click one button, okay, which is predict. Okay, so it will be automatically start predicting. Okay, so yes, so you can see, yes, this is the web app I have implemented. Okay, so I'm not good on like designing, so I'm not good on designing, but yes, I have done my best. Okay, so you can see this logo has been also implemented by me. And yes, I have told you about classification library. So if you click on find out more, so you can see there is a section. Okay, so you can start with this image seeker library. So you can see everything you need is up and running. Okay, on the website, just open. Okay, so just click here. Okay, get started. So it will automatically like start. Okay, so I will show that, but now let's come why should you use this image seeker library. Okay, so there are some like cons. Okay, so I have figured out. Okay, but I'm telling you, like, I've done this just for learning purpose, but yes, but I've done, so that's why I just want to tell what is the advantage of using this library. Okay, so you can see it's a simple. Okay, so ImageSeeker is a simple, and the ImageSeeker reduces developer time of writing too much of code of any image classification problem. Okay, so that they can focus on just the problem. Okay, so they don't have to worry about the coding. Okay, so what they need to do, they just need to so they just need to focus on their problem. Okay, so everything would be automated here. Okay, and you can see it's a flexible because I have used this Keras API in the backend. Okay, uh, so you can see, so you already know Keras is a powerful high-level API. Okay, which is running on top of the TensorFlow. Okay, which is implemented by Google. Okay, so yes, so Keras adopts the principle of progressive disclosure of complexity. Okay, so and simple workflow and should be quick and easy. Okay, that's why ImageSeeker is also flexible because it is running on the like Keras. Okay, and you can see it's also powerful because we know Keras is powerful also. Okay, so that's why ImageSeeker is also powerful. And the thing like yes, it has been made with the love, okay, of my lab. And yes, like we'll see. And here are some of the example like what kinds of projects you can do, like every image classification task you can do by using this library. So here's some example. You can see, you can click on that. Okay, so these are the template like I have attached. Okay, but I'm going to like update this like web page. Okay, so that it would be more like interesting. Okay, and you can also download the source code, yeah, because it is open source. I have made it open source. Just you just have to click on this button. Okay, so it will take you to my GitHub, and you can see I have explained all the thing like how why image seeker is important. Okay, and why you need to use this image seeker. So I have compared with the Keras, actually Keras image classification. Okay, so if you want to classify any images and if you want to perform image classification task with Keras. Okay, so so what would be the con? Okay, so you can see, you can compare from here. Okay, so I'm going to like briefly explain like why I've done that. So you can see like whenever we are just trying to make some image classification task on top of Keras. Okay, so what we need to do, we need to write tons of code for that. Okay, so you can see like we need to import all the libraries. Okay, all the necessary libraries, all the necessary tools. Okay, and we have to also define our paths. Okay, and we also and we have to also like take care of our data. Okay, so where is our data presented? Okay, okay, what would be the train test split? Okay, and you can see should we apply augmentation or not. Okay, so each and everything like you have to take care in the Keras one. Okay, and and you can also see like we have to download the model just manually, and we have to also freeze that because these are pre-trained models, so we have to also freeze that layer, otherwise like it will train on top of all layer. Okay, so we don't want that. And we have to also like define our custom layers, because every time this pre-trained layers won't work. Okay, so that's why you have to like attach, so you have to like define some of the custom layers. Okay, so which can like so there would be some parameter. Okay, so which can be trained like which can be changed on top of your data, on top of your problem also. Okay, and you have to define also the loss function and optimizers. Okay, each and everything. And we have to also define your like tensor board like log file. Okay, so what would be your log file, like if you want to compare with if you want to compare your model later. Okay, so you can like define this tensor board. Okay, so it will automatically like store all the logs of your training data, so of your models parameter. Okay, so yes, and you can and you have to also compile the model also, and then you have to like start training. Okay, and yes, so that much of code you need to write in the Keras. So yes, this was the training process of Keras. And if you want to like predict now, okay, so again you have to write like tons of code for that. Okay, so which is really annoying. Okay, we don't want so we are just looking for some kinds of automatic task. Okay, so which would be able to do all of our works. Okay, so now let's come to my my work. Okay, so what I have done. So you can see like you don't have to do anything. First of all, like you have to just clone the this repository. Okay, in your local. And also you can like use your Collab. Okay, I will show you how you can use your Collab. But for the local user, okay, it would be very handy. Okay, so because you can use the like UI. Okay, you can use the user interface for training and predicting. But at the Collab, okay, you have to like write just 4 lines of code, but your work would be done. Okay, so I will show you how you can do that now. Now I will take you through some example like how it works. Okay, so first of all, like after cloning this repo. Okay, so you have to like you have to route your terminal in this project directory, okay, and you have to just write this Python, and you have to just type one command, which is Python main.py. Okay, so if you run that, so it will automatically start, okay, on your local host. And if I show you, so if I open up my local host, so guys, see, if you run your localhost, okay, so this web page will be rendered, okay. So you can see all the things like I have explained right now. And for starting, what you need to do, you just have to click on this start button, okay. So if you click on that, so you will get this page, okay. So here you have to define some of the parameter, okay. Then here you can see there are two buttons. One is start training and one is like predict, okay. So you can use that after filling this form, okay. I mean, configure your after configuring your data and your model, okay. So it is really easy, okay. So you don't have to this is not a rocket science, okay. So this is really very easy. So what you need to do, first of all, here you can see you have to define your training data, okay, your training data directory. So it doesn't matter where is your data are presented, okay. So it doesn't really matter. You don't have to keep your data in the project directory. It can be anywhere, okay. So you have to just define the path, like where is your data, okay. So it will automatically keep that data from there, okay. So I'm going to show you. See, this is my directory, and here you can see I have kept my training data and my validation data, okay. So for this example, I'm going to use this cat dog classification, okay. So it's a so I think you know about cat dog. We are going to classify whether an image would be cat or dog, okay. So I'm going to use that. So here you can see I have two class, one is cat and one is dog, okay. So first of all, I have to give the training give the training data path, okay. So what you have to do, you have to just copy this path, and you have to go back your UI, and you have to just paste here, okay. So you have to just paste here, and then it was your training directory, and now we have to give your validation directory. So that's why uh, I will go my validation directory, and this is my validation directory, and I will just copy that path, and I will just paste it over there, okay. So yes, I have done just two parameter, okay. So one is our training directory and one is our validation directory, okay. So make sure you have to define this two path, otherwise it won't work, okay. And next you have to define what is your class, okay. So I mean, the number of class presented in your data. So you have already seen in my directory there were two classes, one is cat and one is dog, okay. So because we are using this dog cat classification, so here I will just mention two because I have two classes. And here you have to mention your what is your image dimension, okay. So it will depends upon your model, which model you are going to use, okay. So for that you can come here, you have to just write Keras application. If you come here, and you can see here all the model presented, okay. So and you can also see if you go to my UI. So if you click here, see here you can find all the model, okay. Some of the model I haven't used, but which model you are going to use, first of all you have to go, suppose if I want to use this VGC16, okay. So I will go to that VGC16, and I will see what should be the input shape for this model, okay. So if you read that, so you will see input shape has to be 2 to 4 times 2 to 4 times 3, okay. This is your width, this is your height, and this is the channel of your images, okay, because it's a colorful image, okay. So that's why it has 3 channel, okay. So yes, you can see what should be your image dimension, and after seeing your image dimension, you have to come here and you have to define your image dimension, okay. So for that you have to just write what should be your image dimension, okay, which separated by the comma, okay. So you can write that, and it will automatically handle in the backend, okay. So you don't have to worry. And here you can see there is a parameter called do you want to apply data augmentation or not, okay. And if you don't know augmentation, you can So but during like your training, okay, it would be on runtime. Okay, on the runtime it will like apply many like transformation on your data. Like it will rotate your data. Okay, it will change the brightness of your data. Okay, so that kinds of like augmentation, it will be like performing on your data set, so that your data would be like more robust. Okay, and your model can learn like perfectly from that. Okay, so like so you want to apply augmentation or not, you have to define here. So suppose yes, I'm going to use this augmentation technique on my data, so I will like select true. And if you don't want, so you have to like select the none button. Okay, and if you see, this is the batch size, so how many batch you want. Okay, during training, it will depend upon your machine. Okay, if your machine is good, so you can like increase the batch size. Otherwise, like you can keep the very small, it would be like perfect. So for that, like I will use 16. Okay, so that's fine for me right now. And here you have to choose the model, which model you are going to use. So here you can see, here all the model you can see. Okay, which was there, I mean this Keras application. Okay, Keras application. But some of the model I haven't kept, because we don't need that. So what are the model is really very important, so I've just kept that. Okay, so later on I can do that, but just you can say this is the demonstration purpose, like I have shown. Okay, and yes, you can select the model. So suppose for that I'm going to use this VGZ16. Okay, so I will select this VGZ16. And after that, like you have to like mention like what would be your model name. Okay, so like it will save the model in your directory, so that you can use that model for predicting on top of new images. Okay, so I will just keep like VGZ 16. Okay, like say, okay, I will just mention VGZ 16. Okay, so this is the model name I want to save. So you can give any name, okay, which you prefer. And there is another parameter called freezing layers. Okay, so if you want to freeze all the layers, okay, so you can like select true, otherwise you can select none. Okay, so for that I will use true, because I'm using this pre-trained model. Okay, so we know pre-trained model like already have trained on some of the classes. Like we know they are trained on the ImageNet data set. Okay, so there are lots of classes. Okay, so this model are educated, you can say. Okay, so we don't have to teach much. Okay, so just I'm telling you in a fun way. Okay, so yes, after that, like you have to select your optimizer. Okay, which optimizer you want to use. So for that, like I have kept two optimizer, but later on I can define more optimizer. Okay, so I will use the Adam, because Adam is good, and it is fast also. Okay, so you can use Adam. And you have to define the epochs, number of epochs, how many number of epochs you want to train. Okay, so you have to just mention that. So right now I will use less number of epochs, because otherwise this video would be very I mean long. Okay, so like I will mention just 5 epochs. Okay, and 5 epochs I'm going to train my model, and we will see the performance of the model. Okay, so if you have selected all the parameters, so you don't have to do anything right now. So you have to just come here, and you have like you are seeing like there is a button called start training. Okay, so if you click on that, so your training would be start. So you can see this is loading. Okay, this is getting loading. And if you want to see the training, so you have to like open up your terminal. And if you like look at that, okay, so you can see there are some logs. It is generating like uh, it has like detected your model. Okay, and it has also like you have done the freezing operation, so you can see it has freezed your layers. And what is the activation function? Okay, it has applied, you can see it has applied the sigmoid, because we have two class. Okay, it will automatically detect. Okay, so whether you have two class or more than two class. Okay, if you have more than two class, it will automatically apply the softmax one, otherwise it will apply the sigmoid function. And see, it has also applied this augmentation. Okay, and you can see like yes, it is preparing for training. And you can see all the log would be saved at this location. Okay, like TensorBoard log feeds. Okay, so later on you can like run that and you can see what is your model performance. Okay, so guys, it will be starting training. Okay, and for that, like I will wait till the end. Okay, and I will pause the video, and after training I will be come back. Okay, so guys, you can see it has already started training, and see, this is the progress is going on. Okay, and let's see. So guys, you can see our training is already done. Okay, so yes, you can see, and because I have trained with the less epochs. Okay, so that's why this score are really like not good, but yeah, that is good, because if you can see the val accuracy. Okay, so it is almost uh, 89%. Okay, so yes, this is good so this is good for now. Okay, and if you really want to like get a good model. Okay, so you have to like train more epochs, otherwise like it would be um, worst model. Okay, so like for getting good model, you have to like train with high number of epochs. Okay, so yes, we have done our training, and if you go to the folder right now. Okay, so yes, this is my project directory. That means this is the whole code, okay, of my library. Okay, I have written, and you can see it has automatically like generated this checkpoint for your model, and you can see also it has saved your model. Okay, like we had used this VGG16, so you can see in the directory. Okay, VGG16 is there. Okay, so if I like increase the size, so you can see, yes, VGG16 is there. Actually, before recording this video, I was like practicing, so that's why like I had used another VGG16, so that's why like it has saved there. But if you see, like this is our recent model. Okay, and we'll be utilizing that for our predicting purpose. And you can also like see this tensor board directory, and if you go to that directory, and you can see all the logs like it has generated. Okay, like for your training and for your validation. Okay, so we will also see how we can see um, of this log. So for seeing the log, okay, so you don't have to do anything, just you have to like go open up your terminal. Okay, so I have opened up my terminal, and if you just write one command. Okay, so I'm showing you. So this is the command, guys. See, this is the command you have to like run. Just you have to like remove that parameter from there, like this percentage sign, and I'm just removing this percentage sign. I mean, on top of this tensor board, and if you just run that, if you just hit enter, so you will see like it will open up a new localhost for you. Okay, and see, this is the link. Okay, you have to copy. So you have to copy that link, and you have to go to your browser again, and you have to just paste it over there. Okay, so if you like hit enter, so you will see your tensor board like will be open. Okay, so yes, you can see like actually, guys, I have just stopped the training. After two epochs. Okay, so that's why you can see it has performed two epochs here. Okay, because it was like taking much time, because I don't have any GPU in my system. Okay, so that's why. But if you have GPU, okay, so it will take less time for you. Okay, so just for like showing purpose, like I have done. Okay, but you can do, okay, with more epochs, you can get good, good model. So you can see uh, by just two epochs. Okay, so what is the val accuracy. Okay, and what is your like training accuracy. So you can see here, and you can compare here. So these are the log, and you can like play with that. Okay, so you can see there are lots of graphical like interface. Okay, so you can click on that, and this is by default. Okay, so you can also change that. Okay, so you can explore. Okay, I'm not going to discuss, because I think most of you know that. And you can see also there are time series also. Okay, so you can also like compare like what is your how many epochs. Okay, after how many epochs, what is your train and val accuracy and train and val loss. Okay, so you can compare from here. Okay, and if I go to my like UI, so you can see it has done the training, and now we have done our training. Okay, now what we have to do, we just have to like click on this predict. Okay, so it will automatically pick up your recent version of the model which you have trained. Okay, and it will be start like predicting on top of that. Okay, so like you have to just click on this predict button. So now if you click on this predict button, so yes, you will see that kinds of UI. Okay, and from there you can predict any kinds of images. Okay, so here you can see there are two buttons. You can upload any images. Okay, which is presented in your test directory or your test data. Like you just want to verify whether your model is performing good or not. Okay, like you don't have to like create any kinds of EI for that. Okay, so like it has the UI. Okay, so you just have to like upload any images. Okay, and you can like see the result here. So if I click on upload button, and if I like open up my like data folder, so yes, I'm selecting an images. Okay, so if I select any images, so you can see this is a dog. Okay, so if I like now click on this predict button, so you will see it is predicting. Okay, so which and you can see the result. Okay, I don't know you can see or not, but yes, you can see it has predicted dog. Okay, it has predicted correctly. So yes, you can like do that by just hitting two clicks. Okay, so you can uh, do the classification of any model with any kinds of data. Okay, this is really very amazing, right? And yes, actually I have done this whole classification task automatic. Okay, so you don't have to worry about coding and you don't have to worry about your data. Okay, and let's also like give one images of cat. Okay, let's see if it is performing good or not. So I will select one images of cat. Okay, so this is cat, you can see, and if I hit on predict, so you will see yes, it is predicting correct, it is a cat. Okay, so yes guys, you can do any kinds of classification by using this if I go to my like home directory, if I go to my home, okay, by using this ImageSeeker library. Okay, which has been implemented by me. Okay, and it was really fun for me because I was like learning this deep learning, all this stuff. Okay, and I was like thinking I'm doing the all like repetitive code again and again. Okay, so why I mean, shouldn't I make a library, okay, which will do the task automated, okay, for me, so I don't have to like write all the code again and again. Okay, because yes, and I think you got the interest. I think you got the interest from my work. Okay, and just give your feedback. Okay, and I'm also going to like update this library as I can. Like I want to like automate all the stuff and so that an user doesn't have to worry about. Okay, now I'm going to show like I have done the locally so local training, how you can do that, and local prediction. And if I talk about if you want to like use it in Collab. Okay, so there is like if you download that, so you will see there is another like file which is tutorial.ipyn file. Okay, so you can just copy whole all these projects in your Google Drive, and you can open up there. Okay, and the process would be same. Okay, and here like you have to mention. So if I open up my this CSV file, so in this CSV file, like you have to mention whatever you have mentioned in the UI. Okay, so you can mention that. So it will automatically pick up from there. Okay, so you don't have to worry about. So you can mention that all the parameter, and you can copy this folder in your Google Drive, and you can see there is a tutorial.ipynb file. So you can open up that by using Collab. Okay, right now I'm using my local. Okay, but you can use your Collab, and here you can see like all the beginners tutorial, like how you can run how you can like run that command, or how you can like start training. Okay, all the things I have written here and I have mentioned here. Okay, so you can like go through this notebook, you will get the idea. Like I'm telling briefly, like you just have to like import some of the necessary library for that. Okay, like from this ImageSeeker library, which will be like helping for training. And here you don't have to like write much of code. Like you just have to like kinds of command. Okay, like four commands. Like if you do that, like your work would be done. Okay, then you have to like just hit this like configuration data. Okay, because you have configured your data, so you have to like verify that. Okay, so that's why you have to reload the configuration file, and you have to like reload this configuration your model. Okay, after that, like here you just have to like run this train underscore engine dot train. Okay, so this train engine automatically start your training, and you can see all the log has been generated, and you can see this is your model like performance. You can see there, and you can also like see what is your image classes. Okay, so for that like you can use that command, and if you want to like predict I mean an images in your like a prediction directory. Okay, I mean your test directory, so you can like also predict by using that command also, and you can like also see the tensor board on top of this Jupyter notebook. Okay, so it is really very handy. Okay, so you don't have to worry, but the fun purpose is like this UI. Okay, so you can use that UI, so you don't have to write any kinds of code, you don't have to like you don't have to prepare your data. Okay, as well, so what you have to do is just you have to like click three button. Okay, your work will be done. So yes, this was all about my projects. Okay, and if you really want to like explore about my projects, so you can go to my github. Okay, and you can just read there. Okay, I will update that repository because I mean I have done some changes in my existing code. Okay, but I haven't updated my repository yet, but I will update that, so you can go through that. You will get some idea like how I have implemented it. Okay, and again I'm telling you just guys, this is for learning purpose only. Okay, so yes, but yes, I mean that will help people. Okay, because the perspective of this project is to like automate whole this image classification task. Okay, and at the end like I just want to give some acknowledgements. Okay, actually I really want to thank uh, Sunny sir. Okay, Sunny Bhavin Chandra sir from iNeuron, and also I want to thank Paul Franshu Paul sir. So I want to thank my mentors Sudhanshu Kumar sir and Krishnak sir. Okay, so they're really great. Whatever I have learned till now, okay, I've been able to learn all this stuff like for them. Okay, so they really supported me. Okay, and yes, I and again I want to thank the whole iNeuron team. Okay, so because they are doing really great job. Okay, and yes, thank you iNeuron, and thank you Sunny sir, thank you, Sudhanshu sir, and thank you, Sudhanshu Paul sir. Okay, I mean for your outstanding teaching and support. And if I open up my codes, okay, so here you can see all the codes. Okay, and this all code has been done using this modular coding strategy. Okay, so here you can see all the code. Okay, so if you like open this utils file. Okay, so here you can see all the configuration, all the data manager file, like how I have handled each and everything. Okay, so you can go through that. Okay, this is open source, you can get from my github. And yes, this is the code of my library. Okay, so you can explore. So yes guys, this was all about my projects, and I think you have like my projects. Okay, so if you have like my projects, just give your feedback so that I can improve more. Okay, so yes, thank you so much guys for watching this video, and I will see you next time.